Hello, science fans. Are you ready to meet an element that might just surprise you and become your new favorite? Today, we're diving into the fascinating world of chemistry to meet a lesser-known but truly remarkable element, strontium, with the symbol Senior. Strontium is element number 38 on the periodic table, which means every atom of strontium has exactly 38 protons in its nucleus. Think of it as its atomic ID card, unique and unmistakable. It belongs to the alkaline earth metals family, right alongside calcium and magnesium. These elements are known for their shiny appearance and their reactive personalities, making them stand out in the world of metals. You rarely see pure strontium because it reacts so quickly with air, forming a protective layer almost instantly. But don't let that fool you. Strontium is a secret ingredient in many things that make our world more colorful, exciting, and even safer. For example, it's responsible for the brilliant, unforgettable red you see in fireworks lighting up the night sky during celebrations. And did you know strontium played a key role in the technology behind old TV sets, especially those classic cathode ray tubes? Strontium is truly an unsung hero, quietly making a difference in ways most people never realize. Even though it's not as famous as gold or oxygen, strontium's story is packed with surprising connections to history, geology, and even the world of art. Its compounds have been used in paints and to date ancient rocks. So get ready to discover why element 38 strontium deserves a spot on your list of favorites. Let's jump in and explore its amazing secrets together. Every element on the periodic table has its own unique discovery story, often filled with curiosity, persistence, and a bit of luck. The story of strontium begins in the late 1700s, nestled in the quiet village of Strontium, Scotland, a place surrounded by rolling green hills and a sense of mystery in the air. Here, Adair Crawford, a Scottish chemist, encountered a peculiar mineral called strontianite. He noticed it behaved differently from the familiar barium minerals, especially when it was heated and produced flames that burned with a brilliant, unmistakable red color. Intrigued by these unusual properties, Crawford carefully documented his experiments and published his findings, boldly suggesting that a brand new element might be hidden within the mineral. Not long after, Thomas Charles Hope, another dedicated scientist, took up the challenge. Through a series of meticulous experiments, Hope confirmed Crawford's suspicions, demonstrating the mineral's unique characteristics and the spectacular crimson flame it produced, something no other mineral could replicate. Hope proposed the name strontites for this mysterious new element, a name that would later evolve into the strontium we know today. Interestingly, despite their groundbreaking work, neither Crawford nor Hope ever managed to see pure strontium metal. Their experiments were limited to its compounds, leaving the true nature of the element still shrouded in mystery. It wasn't until 1808, decades later, that the renowned chemist Sir Humphry Davy finally isolated pure strontium using the process of electrolysis, revealing the shiny silvery metal hidden inside the mineral for the very first time. The discovery of strontium was truly a team effort, spanning years, multiple experiments, and the combined brilliance of several scientific minds working across generations. Science, after all, is rarely the work of a single person. It's a collaborative journey where each discovery builds on the work of those who came before. From the quiet Scottish village of Strontium to the bustling laboratories of Europe, strontium's story is a testament to the power of curiosity, teamwork, and the relentless pursuit of knowledge. Sometimes the path to discovery is as fascinating and inspiring as the element itself, filled with unexpected twists and moments of wonder. And that's the real magic of science, an endless adventure of exploration and discovery. So, what is strontium actually like? If you could hold a piece of pure strontium in your hand, you'd notice it's a soft silvery white metal with a subtle pale yellow tint. It almost looks like a chunk of shiny, precious metal, but it's much softer and lighter than you might expect. Pure strontium is quite striking. Its surface gleams with a metallic luster, and it's so malleable you could easily cut it with a knife. But this beautiful appearance is fleeting. The moment strontium is exposed to air, it reacts almost instantly with oxygen and moisture, forming a yellowish oxide layer that quickly dulls its shine. This reaction happens so fast that it's rare to see strontium in its pure, untarnished state outside of a laboratory. If you cut a fresh piece, you'll see a bright, shiny surface for just a few moments before it turns dull and yellowish as it reacts with the air. This rapid tarnishing is a hallmark of reactive metals like strontium. At room temperature, strontium is a solid metal, but it melts at 777 degrees Celsius and boils at 1,382 degrees Celsius, relatively low temperatures compared to many other metals. This means it can be melted and manipulated in the lab without extreme heat. But strontium's most famous property isn't its appearance. It's the brilliant crimson-red color it produces when heated. Both strontium metal and its compounds emit this vivid red light, making them instantly recognizable in flame tests. This red glow is strontium's atomic fingerprint. Just as sodium burns with a bright yellow flame and barium glows green, strontium's red is unmistakable and unique among the elements. The color comes from strontium's electrons getting excited by heat and then releasing energy as red light when they return to their normal state. This process is a beautiful demonstration of atomic physics in action. That's why strontium is the star ingredient in red fireworks and emergency flares. Its vivid color is both eye-catching and practical, used for signaling and celebration around the world. So, even if you never see pure strontium metal, you've almost certainly witnessed its signature crimson color lighting up the night sky. That's strontium's chemistry in action, turning science into spectacle. You won't find pure strontium lying around. It's always locked in minerals within the Earth's crust. Strontium is actually the 15th most abundant element in the crust, but it's always part of a compound. The main sources are two minerals: celestite, strontium sulfate, which forms beautiful blue crystals, and strontianite, strontium carbonate, the mineral that started it all. Celestite is found in sedimentary rocks, while strontianite forms in hydrothermal veins. Today, China, Spain and Mexico are the top producers of celestite, mining it from ancient geological formations. Geologists hunt for these mineral-rich rocks, unlocking strontium for everything from fireworks to electronics. Strontium is everywhere, just hidden in plain sight. How do we get strontium out of rocks? It's all about clever chemistry. The process starts by crushing celestite into powder and roasting it with carbon, turning it into strontium sulfide. This compound is then converted into strontium carbonate, a stable white powder used as the starting point for most strontium products. For pure metal, strontium oxide is heated with aluminum in a vacuum, a process called aluminothermic reduction. The result, pure liquid strontium, which is then distilled for extra purity. It's a complex, energy-intensive journey from mineral to metal. Most strontium is used as compounds, not pure metal, because the extraction is so involved. Chemistry unlocks the element's potential, transforming dusty rocks into useful materials. That's the science behind the scenes. Ever marveled at a deep red firework? That's strontium at work. Pyrotechnicians use strontium compounds, like strontium nitrate or carbonate, to create those vivid crimson bursts. When heated, strontium's electrons get excited and release energy as red light, a perfect match for fireworks. This same principle powers emergency road flares, which burn bright red thanks to strontium. The color is so intense, it's visible even in bad weather or at night. Strontium's unique chemistry makes celebrations more spectacular and keeps us safe in emergencies. It's a beautiful example of atomic physics lighting up our world. Next time you see a red firework, you'll know the science behind the sparkle. Strontium truly brings the wow factor. Strontium isn't just for fireworks. It's been a hidden hero in technology and health. In old TV sets with cathode ray tubes, strontium oxide in the glass blocked harmful X-rays, making TV viewing safe. As TVs evolved, this use declined, but it was once strontium's biggest job. In medicine, strontium ranelate has been used to help treat osteoporosis by strengthening bones. Strontium also powers strong, affordable magnets. Strontium ferrite magnets are found in everything from fridge magnets to electric motors. Its versatility makes it essential in many industries, even if you don't see it. Strontium quietly supports our daily lives, from safety to science. It's the element you never knew you needed. Is strontium safe? For the most part, yes. Stable strontium found in minerals and used in fireworks and glass is non-toxic and handled by our bodies much like calcium. We all have small amounts of stable strontium in our bones from food and water. The danger comes from a radioactive isotope, strontium-90, produced in nuclear reactions. Our bodies can mistake strontium-90 for calcium, absorbing it into bones where its radiation can cause serious health problems. That's why strontium-90 is hazardous, while stable strontium is safe and useful. The key is knowing the difference between the friendly and the dangerous forms. With proper understanding, strontium is a helpful element in our world. We've journeyed from a Scottish village to fireworks and TV screens, discovering strontium's hidden impact. Strontium's superpower is its vibrant red flame, but it's also a quiet guardian, protecting us from radiation and strengthening bones. Its story connects chemistry, geology, physics, and medicine, showing how science is a web of knowledge. Every element has a unique role, and strontium is a perfect example of a hidden hero. Next time you see a red firework, remember the science and teamwork behind it. Strontium proves that even the lesser-known elements make our world safer, more colorful, and more interesting. Sometimes, the most amazing science is found where you least expect it. Consider it.